Okay, so time to do number 7. You have the box right here, the card. You have f of g, which went straight down. Fn, which goes here. And we want to indicate acceleration, and AC always points towards the center. B, in terms of given quantity, acceleration, direct expression with normal force. So Fn x equals to Fc. Yeah. Okay. Again, this would be our plane. C. So Fnx equals to mv squared over r. Fnx equals to mv squared over h tan theta. We get that from the height. To find the distance from the radius. Okay. Now we'll set up Fny, and this should equal to mg. Yeah, because it goes like this. Now we'll find Fn. Fn equals to Fnx squared plus Fny squared. So square as well. Boom. Fn equals to square root of mv squared over h tan theta squared plus mg squared. And that is our answer. C. Draw an expression for the centripetal force in terms of the given quantities and any fundamental constants as appropriate. So we know that Fc equals to Fnx. Fc equals to mv squared over r. Fc equals to mv squared. And then we already found r to be h tan theta. Okay. Time for D. I need expression for V. So Fc equals to Fnx. Mv squared over r equals to Fn cosine theta. Mv squared, r is h tan theta. And then we know Fn is mg sine theta from the Fny equals mg equation times cosine theta. We can cancel out one of the m. We cancel out the m's. So we get v squared over h tan theta equals to cosine theta over sine theta. Move this over to the side. So that's cotan theta times the g. Look at the g. G cotangent theta times h tan theta. These two are inverses, so they cancel out. So we get v squared equals g times h, and v equals square root of gh. Time for E. So we have Fny minus Fg minus Fsy, friction now, equals to 0, because the car does not slip, so it does not go up or down. Fn sine theta minus Fs cosine theta, and I'll move Fg to the other side. Fn sine theta. Oh, the n looks like it's a minus Fn mu s cosine theta equals mg. We can factor out an Fn, so it's just sine theta minus mu s cosine theta plus mg. Move that to the other side. mg over sine theta minus mu s cosine theta. Okay. Then we have, I'll find fn in the x direction, x plus fsx, it will, because both point to the center, so this is fn cosine theta plus fs sine theta equals to fc, fn cosine theta equals to fn, no, plus, hold on, mu s sine theta equals to mv squared over r. Actually, max. So we have, again, we factor out the the fn plus mu s sine theta equals to mv max over r. And now we already found fn here. We'll plug it in for this fn, so it's mg over, sine theta minus mu s cosine theta. And this is times cosine theta plus mu s sine theta. And this all equals to mv squared v max r, cancel out an m. I'll multiply the r over, so we have rg cosine theta plus mu s sine theta. It's all over sine theta minus mu s.
Austin?
Yeah, wait, give me a sec.
Wait.
My brother. Okay. Cosine theta. Because v square max. And then we square root both sides and we have our answer. So v max, this is the square root of rg cosine theta plus mu s sine theta over sine theta minus mu s cosine theta. F. Now we want speed. Now we want minimum speed. Okay, wait, let me check something. Okay, so we found fn to be mg over sine theta plus mu s cosine theta. We found this up here when we were solving for fn in the y direction, or the net force in the y direction. Now we're going to set up fn in the x direction, fnx minus fsx, and we do minus the sign because we want it to be v min. So fn cosine theta minus fs sine theta equals to mv squared, and this is a min this time, r. Fn cosine theta, again we'll expand it, us sine theta equals to mv squared min r. Factor out the fn's and then plug it in. So I'm just gonna really do that up here in this step. So I'm just gonna no more fn us sine theta so mv squared is the min r. Plug it in, mg sine theta plus mu s cosine theta. Again, all times this minus mu s sine theta equals to mv squared min r. Cancel out the m's. Move over the r. Cosine theta minus mu s sine theta all over sine theta plus mu s cosine theta equals v squared min square root both sides, and we have our v min. So our v min equals to the square root of rg cosine, why am I going like that? Cosine theta minus mu s sine theta all over sine theta plus mu s cosine theta. Lastly, g, I'm going to prove f net equals that. So first, I'll set up net force equation. Net force equals Fc. Means net force equals mv squared over r. Oh my god, chill. Net force, so we want to set up to the the V max equation. So net force equals to m, and then V max. Where is it? Can I copy paste? Oh, please work. Okay, it won't let me copy paste. How do we rewrite the whole thing? Okay. So this is m on the outside. That's rg cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta. This is all squared over r. So net force equals to m times rg cosine theta plus mu s sine theta over sine theta minus mu s cosine theta over r. Cancel these r's out. So f equals to just mg cosine theta plus mu s sine theta over sine theta minus mu s cosine theta. We can multiply the top and the bottom by 1 over sine theta, which is the same as multiplying by 1. So we get mg cotangent theta and then the mu s, and then the sine inside gets cancelled out. Just add mu s, and then the bottom, the bottom sign gets cancelled out, becomes 1, and then it's mu s cotangent theta. And that is my answer.